So welcome to Introduction to Chaos Engineering, and I know that you guys have a little bit knowledge what is chaos engineering. I mean, a little bit idea. So, so just before starting, I started on this topic around 1 2 years ago, and since this chaos engineering was quite a buzzword that time, even now it is now here as well. So I really wanted to know few questions, answer a few questions which I had in mind at that time. The first one is obviously like what is chaos engineering and what problem does it solve, and where does it fit in the delivery life cycle? Does it go beyond infrastructure chaos, such as turn off that machine and simulate CPU spikes, like the thing which me and Yes was discussing another day? That the chaos engineering means just to shut down this machine and kill that process, or does it mean more than that? So I have this pretty much questions. And also the chaos engineering is pretty much engaged with cloud native applications. So like we can use only for cloud native applications, or we can use it for the traditional stack as well. Which, I mean, I had this question, but maybe not very relevant for uh, us as of now. And then if we do something, we want to measure it. So like if we do chaos engineering, how to measure it, whether it was successful or not. So these kind of things, and like what is the role of monitoring and observability in this, and how does one get started if you understand all the things like we are planning to do for CPro? How are we are going to start? Like what is game day basically? And last but not the least, how it is different than the traditional software testing. So that was the most important question for me, because I was doing load testing, and so whenever we do load testing, we see, I mean, the CPU is spiked up to 80 90%, and we see some issues in the application. And the similar thing I was seeing in chaos engineering, that artificially you are simulating CPU to 80 90%. So I was not sure, okay, then things are same or different. So how it is different from the traditional testing? These were the questions which I had, and in this short discussion or the presentation, I'm going to trying to answer these questions for you guys. So let's start with what is chaos engineering. And if you Google it, you will get something like this. Chaos engineering is the discipline of experimenting on a system in order to build confidence in systems capability to withstand turbulent conditions in the production, which might not make much sense because there's so many words there. In simple words, it is thoughtful, planned experiments designed to reveal the weakness in systems. In short and simple words, crisp words. Basically, you have to think something, and you have to plan an experiment around that, so that you can reveal the weakness in your software system. Maybe hardware, maybe software system, anything it is. Now we know what is chaos engineering. Question arises, why do we need chaos engineering? So nowadays, uh, most of the companies, they are moving toward microservice architecture because it provides you flexibility, and there are so many connections. I don't know what is happening to my slide. Yeah. So basically, if you see these microservice architectures, they are very complex and distributed, and there are countless number of connections and dependencies with each other, right? So it is practically very difficult to test each and everything from traditional QA practices. So you really want a mechanism where you can test these things proactively. I mean, you find them before they find the customers find those kind of issues. So that's why we need chaos engineering, so that we can find issues in the large distributed systems. Yeah. And obviously, one more very good feature I found for chaos engineering is training of our reliability engineers, so that we can plan. Like I was discussing about game day, right? So like we can plan something, and one reliability engineer should be there on call, so that they know if something happens, like why it is happening, and like how much time it is going to take to keep things moving on. So the in real time production, if you get these kind of issues, you know, your reliability engineers know how to solve it. So it's kind of a game day for them as well. So so I mean, so these were the things, what, why, and all. And now the question arises, how you do chaos engineering. So as the word suggests, chaos, it's really very structured practice actually. So there are few principles of chaos engineering, which are like, you can see here, and we are going to see these principles in detail, so that you will get one idea, okay, how we are going to perform our chaos engineering. And this is not all theory. I'm going to show a demo as well in Azure with the tool called Gremlin. So just bear with me for like few more some time. The first principle is define steady state. So, what is steady state? Steady state is nothing but the normal behavior of a system over time. So, what is a normal behavior of a system over time? Let's say I am a user of a bank website and I want to check my statement, account statement. So, for that, I will type my username, my password, and log into the bank website. I go inside, I'll do whatever I want to do. So this is a normal behavior of a system. That system is ideal. You can go, you can put your username, password, click on login button, you will go. So basically, that is a steady state for your banking application, a login page, basically. Then, if you know your steady state, basically, then you want to have few system metrics and business metrics. Now, what is system metrics? So, system metrics are metrics which you are getting from your system, maybe your operating system, maybe your application, right? Like that. I'm not sure why what is happening to my laptop now. So you see system metrics are like latency, number of errors thrown over a period, result from health and endpoint, average CPU, memory, and all those kinds of things which we get from the systems. And what are business metrics? Business metrics are number of login per minute during the peak, basically those metrics which you need for the business, right? Or maybe number of failed logins per minute, number of declined transactions per second. And generally business metrics are more useful. And so basically that is your steady state. So you have to define a steady state, basically what you are going to test, what is your objective. After that, you have to form your hypothesis. So you have to use these kind of words, like use what if to find it. For an example, if a random virtual machine is terminated, then failures are negligible. Basically, that is your hypothesis. And from negligible, you are going to say that less than 10 failure logins per 10,000 logins. So that is a negligible for you. Let's say you have a fleet of 50 virtual machines and one random virtual machine is terminated, then failures are negligible. That is your hypothesis. Okay. Or if a geographical region fails, then application will be down for 5 minutes, but a static site will serve some basic information. So like you are the guys who build C Pro and you knows application from in and out. So uh, it's very easy for you guys to build a hypothesis, and it's always in the scientific method. Or the first thing is always fix the known problems first, and after that you have to uh, do hypothesis. Okay, moving forward, I mean, yeah, there are a few more examples, right, for your hypothesis. Then the third step says plan and run your experiment. So now we know our steady state. We have built an hypothesis. Now we have to plan and run an experiment. So to planning, so basically you need to gather all the stakeholders, right? Or get all the stakeholders, look at the architecture of your application, what is what, where we are going to put the, where we are going to inject the failure or something like that. And then you have to contain the blast radius. So contain the blast radius is, again, I was telling you, let's say we have a fleet of 50 virtual machines, and generally, let's say those are in a production, right? And you really don't want to put the chaos or this kind of failures in all the 50 virtual machines, because then your customer will suffer. So let's say you decided to keep these things only in one virtual machine, and so that's how you have to contain the blast radius. Basically, you are defining your scope. Okay, that I'm going to put this chaos engineering in only one, two, three systems, not in all. And when you are planning for this kind of exercise, plan your notify your organization, maybe your on-call training in your system engineers or whatever, that okay, we are going to run this chaos experiment. So if something goes down, be ready and have a stop button ready. So let's say you planned to do chaos or inject failure in only in one virtual machine, but somehow there was a weakness that it is affecting other down systems or other virtual machines anyhow. So basically, you are going to ruin all the production things, right? So you have to have a stop button ready. So if something goes wrong, you have to abort the test, right? So that is how you plan and run your experiment. And the last step is measure and learn. So use your metrics to prove or disapprove the hypothesis. Was the system resilient to the injected failure? You have to ask this kind of questions. Did anything unexpected happen? And then share our progress and success and repeat. So in short, whatever we have seen here is we can is everything is like here consolidated. So like you have a steady state defined, then you created a hypothesis, you ran an experiment, experiment was success, very nice, scale up and now repeat. Or if your experiment was failed, find and fix the issue and also abort the conditions, and don't forget to minimize the blast radius. That's how structured chaos engineering is. It's only the name in the chaos, but it is very structured. Now, if I move forward, and the main question which I had, how it is different than the testing. So I actually searched on many places, and what I found, testing is basically kind of a validation where you know this is the input, that is the output, and you validate it. But chaos engineering is all about experimentation, where you make hypothesis. It hypothesis could be like anything, right? Because you know your system, you can make some hypothesis, and then you do some experimentations which nobody has done. Because let's say you have a microservice architecture. This service A is talking to service B, service C, service Z. I don't know, and it's your hypothesis is your thinking might be how A can affect to C or D, and then you have to plan experiments accordingly to prove or disprove your theory. So that is how it is different than the regular traditional testing. I would say chaos engineering is or chaos engineering is also known as reliability engineering, resiliency engineering, or resiliency testing. So it's a testing of modern era, I would say. For me, that's what I understood. Now, you know what is it, why we want to do it, how it is different from testing, what are the principles, everything you know. The main thing is before you start, we have to have few things in place. So for us, let's say if you talk about CPRO, so the first thing is observability or monitoring. So we have to make sure that our systems emits data. What kind of data? Like the system data, logs, traces, logs, matrices, and there should be some platform where we can see all the things. So if we measure the things, only then we can improve the things, right? So we should have very nice monitoring system in place. We should have this on-call training engineer on standby. So if something goes wrong, he or she should be able to respond and help. And obviously, we have to measure. We have to measure your chaos engineering success in terms of revenue. So if chaos engineering was there, we saved that much thing, because if that failure would have occurred in production, how much it would have costed you. So then why you will get to know, okay, whether your chaos experiment or your game day was successful or not. So we should have these things in advance to start chaos engineering. Now, we have seen enough theory, and now we know basics of chaos experiments, like how and what we do. So basically, this is a kind of experiment which you can think upon for on your application. So let's say on resource level, and you want to do some CPU. And now going to use what attacks, because I am going to show you a demo on Gremlin, and Gremlin use this what attack. So basically, I want to do a CPU attack on my application. I want to do a memory attack on my application. So basically, I'll keep the CPU 90%, and I'll see how application works or how my monitoring system works. Is it detects the CPU hike or not? Similarly with memory, IO, disk. Then on infrastructure level, again, I can shut down machine and I can see how application reacts or what different kind of things happens. The time travel is a very interesting, and you can basically change the system time and date in your server to see what happens, because now we are working with the different time zones, and in the March, the DST time saving will be off or on, I don't know. I mean, the time will change, right? 1 hour. And basically what it does, and there is one very good example from Azure in 2012, I believe. So basically, there was a program was written to check the availability of certificate for 1 year from today's date. So basically, when 29th February came, so there was no 29th February 2013. So basically, it went down, and for 8 hours there were downtime because of that. So these kind of things. I mean, yeah, again, this is your imagination hypothesis. You can use that. Then the process killer. You can kill any specific process in your application and see, okay, what happens. Similarly, on network level, we have a black hole attack. So basically, your two services are talking. You drop the IP. Basically, you black out the communication between them and see what happens to the other services or to with them. Then there is latency. You inject some latency and see how your customer behavior is. Packet loss. So basically, you can do some 50% packet loss on cPro website, and you can see, okay, how customers of cPro or maybe users of cPro see their homepage. Maybe there is no login button or no add test button. I mean, basically that is missing if we are removing some packets because of network issues, right? And then DNS thing, then application level, again, you can play with serverless. You can inject some coding, and on JVM level also you can inject some kind of failure. So there is, I mean, sky is the limit. These are like pretty normal things which people use, and we can also use, right? There are a few more options which we can think of. So this is an example architecture from Google Hipster Shop app. Okay, and here you can see, I mean, yeah, a microservice architecture, and I have taken one snapshot from. So basically, what this snapshot tells us, I mean, this is how the chaos engineering result card look like for that application. Basically, application name was Hipster Shop, and we used a gremlin attack called Black Hole, and scope of the failure was at service. Duration of the failure was 120 seconds. So basically, uh, they drop all IP tables of this black hole service of this ad service, and for 2 minutes. And there was some abort conditions when I said you that you have should have a stop button. So you should press the stop button when you have this 400 500 errors in this 2 minutes, or you see any browser test fails, or your Dynatrace identifies any problem. And hypothesis were the performance will be degraded, and their conclusion was like this, and that's what the result is. So application handled ad server going down, dig deeper to monitor it. I mean, if there was some errors or like that. So I mean, this is a pretty much example, a result card, how it looked like. So if we will be doing that, we can make our own, or we can follow this, something like that. Now, if we talk about tools for chaos engineering, so there are Chaos Monkey. Chaos Monkey was one of the first tool which came in 2010, almost 11, 12 years old, coming from Netflix. And then there were so many tools for Kubernetes, Scoop Monkey, Chaos Toolkit, SteadyBit, whatnot. So Gremlin, INC, they are providing failure as a service. And I'm going to give you demo on this Gremlin, right? And then obviously chaos engineering we can fit in a pipeline as well. So question is, can we use this in our context? Let me show you guys the. So this is how a Gremlin looks like, the tool. And today what I'm so basically this is dashboard. I am having one free account, and what did I do? I created one VM in Azure, which I named Chaos VM, and it's not a fancy. I mean, normal things. And if I go to the monitoring tab, so my hypothesis is let me. So I have logged into this VM here. Oops, what happens? So my hypothesis is, if I put load on my this if I do some CPU attack on my this virtual machine, Azure monitor should be able to detect that spike. That is my hypothesis. If I do CPU spike in Azure VM, then Azure monitor should find it, I say, or display it, whatever, right? That is my hypothesis. And you see, this is a CPU graph, basically, yeah. And if I have already installed all the Gremlin related stuff to this virtual machine, so that I mean that is also very simple. So that you see one active client here. Now I'm going to attacks, and before going to attack, let me see if I have some monitoring in my system as or not. Nmon, yes, I do have nmon. And if I do L, so nmon is basically nmon is basically a tool for monitoring Linux resources. And if I put keep L, then I'll see the CPU long term, CPU usage of my machine. If you see, there is CPU usage is almost negligible. Now what I'm going to do, I'm going to attack this, a new attack on infrastructure level. One host is available. I have to select the host. So this host is selected now. And I have to choose a gremlin. So I'll go on resource. I'll select the CPU. Length of this attack, I'm going to put it again 2 minutes. CPU capacity, I'm going to put 90% load. I want all codes to be spiked. And now I'm going to run the attack and unleash Kremlin. Let's see. You see, started CPU spike up to 90%, you see here. And if I go to my tool, the Linux monitoring tool, which is on my machine, I see the 90% CPU is being utilized now. Now, as per my hypothesis, my Azure monitor should also detect this thing. And let me go to my Azure monitor. So basically, this is the time February 17 and 3:27 p.m. Yeah, so at this point, I don't see anything here as of now. I don't see any spike. But my Linux tool is telling me, yes, CPU is utilized 90% now. And the Gremlin is also telling me, yes. So this is the stop button. If something goes wrong, I could use halt all attacks like that, which I was telling you guys during the theory. Yeah, still 90%, and my Azure monitor is not showing me anything as of now. Let's wait for one more minute.
Is it slow to update the Azure monitor?
I don't know. I mean, I have no idea. That was my hypothesis. Let's see what it does. Maybe I can refresh it, and if it does not, and if our hypothesis is wrong, then maybe we can go and have a word with Microsoft, right? So that's what it is, right? So that's what the aim of chaos engineering, to find the weakness in your system or some things which are not supposed to be there. And if I go and you see, still I don't see. Now it's 3:28. Our test started at 3:28, and if I see, the test is already stopped now because 2 minutes passed. And if I go to my tool, I see this, now it is clearing it up because now there is 0% load. See,
cool.
So basically, my test, like that, those 2 minutes with the 90% CPU utilization time has passed, but our beloved Azure monitor still not showing up any spike. So that is a finding for me that my hypothesis was wrong, because I have a data which is telling me that your hypothesis is wrong, because there was indeed 90% CPU utilization, and my Nmon tool is telling me that. Somehow now here it comes after my test was stopped. So if you are running some application which is very where the milliseconds are very important, kind of a crypto applications, right, where is everything is happening within milliseconds, and if your system is eating that much CPU, or something CPU related issues are happening, and you are on Azure monitor, and then you will see those things like after 2 minutes. And for those application, 2 minutes are too much, guys.
Yes.
So that is something which you guys expected, because our test was done 2 minutes ago. We started
Hmm.
28, we now done 29, and now it is telling us, okay, there was some CPU spike, like after so.
So now we learned that we should not use Microsoft Azure.
Well, I
Google
won't say
Cloud
that,
instead. Yep.
but I will say that for monitoring of that sensitive application, you should have a better monitoring tool.
Hmm.
Maybe a New Relic or a Dynatrace, or maybe I don't know, App Dynamics, or maybe the native tool which I used, Nmon, which is like although open source. So
Yeah.
so it's like that. I mean, you have to think what could be the weakness, and then you have to go for it. So that's
Yeah.
how it works. That's what I wanted to show you guys, and that's what I want to discuss.